you want to go to like meet at Ropolo's next month, which we could do, but we should not do that in March. That would be a terrible idea. I'm sure the pizza will be fine, but you wouldn't want to be there. So just let us know if y'all have any thoughts. Definitely open to suggestions. Also, as always, if you are interested in giving a talk at some point in the future, I mean, if you got something brief tonight, we're definitely curious, but more for the future. If you've got ideas for talks or whatever, please come reach out to us. We're trying to get things scheduled going out into the 2025 period, and so let us know. Just anything related to Go, and either as a practitioner or cool tools you've seen, libraries you enjoy, even just questions or bugs or whatever that you're wanting to explore. Any topic along these lines are welcome. And if you've never presented at a user group before, we've got a couple people here who have done quite a few, and so we could help you get started on your first time speaking in front of a user group crowd like this. Tonight at first, we've got HD is going to be talking about kind of some interesting topics, and then afterwards I've got just a brief discussion as well. So yeah. Any questions or thoughts before we get started? All right. Here is HD.
Cool. Hey, folks. So kind of echoing Charlie. Charlie is the organizer. I am the discount Charlie. So talk to him first, but I can be backup if you need help with anything. What I love about user groups and talks like this is you can talk about anything. And the idea is, like, a lot of people worry about looking stupid. No, the whole goal is to look stupid. The goal is to share, like, here's something I struggled with that you guys probably know better. Tell me what I'm doing wrong, or to get a different perspective. So even if you're new to Go, we'd love to hear, like, what are you struggling with learning? What are the things that don't make sense to you in the current Go? Like I would tell you now, if I had to come into Go starting today, and the first thing I did was read about generics, I'd run away screaming and learn Rust. So, I mean, now that I've been using it for a while, I understand what the point of them and all that fun stuff. But there's definitely, like, always keep in mind the experience of a new person is very different than the experience you may have yourself. So it's always good to kind of hear, like, that fresh take about, I tried to use this tool or this kit and it doesn't work the way I want. So don't worry about looking, silly. That's kind of the whole point of this stuff, to share kind of what we're good at, what we're struggling with, what we know, what we don't know. So quick intro, my name's H. Seymour. I'm the founder of a company called Run Zero. Prior to that, I started a thing called Metasploit, did that for a long time. I've been in Austin since like the 80s when it was cheap. It's no longer cheap. So I love supporting local groups. In addition to the Go one, I also help out with the Austin Hackers, which are once a month, kind of like Fight Club rules. You show up in a dark room in a bar and you talk about stuff that you can't share outside the bar. And we do 10-minute talks back to back for 2 hours straight while everyone, like, furiously drinks. So I'll call our water or coffee, whatever you like. But yeah, so it's a kind of a fun crowd. So if you're curious about the hacker side of things, check out AHA too. So this is a talk I did at LastCon it's kind of a work in project, or work in progress in a lot of ways. It's kind of like my view of exploring, like, number systems. So let me actually shift over to the right deck here. There we go. And see if I can click things that are way over there. Yep. Where is the other window? Theoretically, I've got another browser window that is the better version of this. All right, one sec. Let me flip back over to just mirrored mode. This extended screen thing isn't working for me. And so I guess first off, has anyone here used SlideDev before? sli.dev. If you really hate giving talks and working on your slides and you'd rather be writing code instead, this is the way to, like, pretend you're still working on your slides while writing code. So the whole thing is just a JavaScript framework, and you just build your slide deck as a Vue app, which is kind of fun. So you can have backend components, you have all kinds of embedded stuff. So everything you're seeing here today is actually live code, which is kind of fun, and it's a little risky to do live demos with, but we'll see how it goes. So and kind of my work is very much like exploring weird number systems, like whether it's trying to figure out like what IP ranges something has, how a MAC address is being allocated, doing a fingerprinting based on ID numbers. It's just basically looking at numbers all day long. So if anyone here is a fan of the Number Wang game show from a certain British comedy, this is basically the Number Wang talk. So first off, I want to get to talk to a group called Bellingcat. I don't know if anyone's familiar with Bellingcat. So they're awesome. They do a lot of work that basically doxes authoritarian regimes. They're very good at pissing off assassins, and then not getting killed as a result. So they do a lot of work for human rights that generally puts them at personal risk. And for folks who aren't familiar with the fable behind it, all the mice get together and say, "Screw this cat. We're tired of this cat killing us, doing this stuff, and terrorizing us. Let's put a bell on it." And they all say, "Yes, we're going to put a bell on it." But who's going to do it? So Bellingcat is the group who puts the bell on the cat. So. All right, so just kind of set the stage a little bit. This talk isn't quite specifically Go, but a lot of Go stuff went into building the talk, so give me a little bit of leeway that it's not as Go-y as it could be. Let's say you walk into the DMV down the street, and just out of the blue, you need to get your driver's license renewed, and you get a number. You take a number for the little thing, and it says 74. I'm like, okay, crap. I don't know, is that good or is that bad? Are you going to be there for a long time, or are you going to be there for 5 minutes? Well, you don't really know. All you have is one number, right? So you wait, you sit down, you grab a seat, and someone gives you the stink eye, you kind of scoot over from them, and then you wait for the next number. 5 minutes goes by, and, well, now you're here now serving number 82. It's like, well, crap. Is it going up? Is it going down? Am I going to wait for a full cycle through 100? Is it up to 100? Is it up to 1,000? Like, you don't really have enough information to determine where you are yet. But you spent 5 minutes waiting. So you sit around, you hang out a little bit longer. Okay, now you get number 85. Okay, now you realize you're screwed. You're never going to leave this building again. You'll be there till midnight. So you kind of tuck in, you start playing your games, whatever you want to do on your phone, and then you hear number 67. It's like, well, okay, now I have no idea what's going on. So this whole concept of trying to figure out the size and space and allocation of a number system based on basically build a determine the sequence of a number system from a few samples is best known as the German tank problem, where during World War II, they'd capture German equipment, they'd look at the serial numbers of things like the wheels and the tank treads to other parts of the tank and say, okay, this is serial number 55 of the die mold that made this part. And then later on they'd say, okay, now it's serial number 57. How many tanks could they have made during this period? So at the time, the Allies were, I want to say, assumed that they were making something like, I forget the number offhand, like 450 tanks per month. In reality, after they'd actually won the war, captured all the stuff and gotten the records, the number is actually closer to 250. And the statisticians who were doing this type of number theory stuff actually nailed it. They got like very, very close to the real number of tanks being built just by analyzing the serial numbers of a bunch of parts. So that's kind of what this talk is about, is how do you figure out the space of a number system based on a few samples that you yourself have. So this includes everything from like credit card numbers, documents, your babies, every baby gets a number, patents, cables, passports, phones, cars, all that fun stuff, right? Pins. Every little microsecond we're sitting here is ticking by, and that's getting an ID, and we're logging that someplace. There's at least like 30 systems right now logging every nanosecond that we're sitting here. So most identifiers tend to be short, though. So if you're getting an identifier, you generally want it to be something that you want to be able to remember. You want to be able to say quickly on a phone. You want to type into a touchpad of some sort. The result is that all identifiers tend to be really dense. There's not a lot of empty space in that number. Like, you don't want to have a 15-digit, PIN number to type on your ATM pad. You don't want to have a, 1,000 number long driver's license number because it's a pain in the ass for you to read and use it. So as a result, like, you're kind of limited by the physical system that you're trying to enumerate. You want to have a number that's big enough to encompass the entire range of allocations, but small enough that it's not going to drive everyone crazy trying to use it. So this information ends up getting, basically gets encoded everywhere. Social security numbers are a good example of that. So, I don't know, what's your social security number? Okay, you don't tell me. But basically, the first 3 digits are called the area number. That's usually where the number is allocated. Second 2 are the group number. The group number is always incrementing, and there's actually a document on the SN website, the SSA website, that says, here's the maximum group that we've allocated for this given period in this given area. So if you're hiring somebody and they say, my number is, 575, 24, and you look at the SA website and say, well, the maximum number, group number issued is 23, you know it's a bad social security number. So that's the only real authentication in the sense of SSNs. And the last final 4 is your actual serial number, but 4 digits is 10,000. You're not going to get more than 10,000 numbers out of the last 4 digits. So you've got to really constrain numeric space to enumerate people, basically. And so those numbers are very dense. There's not a lot of empty SSNs. So PIN numbers are another really good example of that. So someone did an analysis of basically the most common PIN numbers through a big data leak. And they created this nice graph where I think the bottom left here is 0000, the top right is 99999, and then here's the graph of most frequent pins across the board. So you see a bunch of patterns jump out right away, right? The diagonal ran. The diagonal is basically the same number, like 4444444 all the way up, or 5 or 6 or 7 or whatnot, right? The bottom left is all the 1 9s and 2 zeros, like your birth year, or the birth year of your kid or your dog or something like that. Then you've got a bunch of little like spots here that are a little interesting. Like some of these are, 7042 is really popular. There's a bunch of like really surprising numbers that jump out, like 5678, 7890, 2468. Well, the ones I love to point out here are that one dark spot. There's one PIN number that nobody uses. So you should use that PIN number. Whatever that one is, I forget it offhand, but it's kind of cool to see how it maps out. So it's also kind of cool to see like what are the patterns. So if you let a user pick a number, the takeaway from this is like if people pick a number, they're going to pick the worst ones, no matter what. Yes, sir.
Another interesting one is there's a yellow dot kind of at the bottom right next to the black dot. Why is what's the top and what's supposed to be?
Oh yeah, right there. That'd be. It's like 80, I think. It'd be 8. I'd have to go look it up. Sorry. There's a great website. So if you wanted to figure out what number it is, you can pull up the portal and probably figure it out pretty quickly based on the frequency graph. But it's also fun just to see like what percentage of all PIN numbers can be guessed in a certain number of tries. So you can guess pretty much a third of all PIN numbers in 61 tries, no matter what. What's also interesting is like oftentimes we get an identifier that doesn't look like a number. It looks like a bunch of letters, but it really is a number when it comes down to it. They're usually just some form of encoded numbering system. So Dell service tags are a really fun one. If you've ever seen like a Dell service tag, it's usually like 6 to 7 characters. Then you see a Dell Express ID, which is a sequence of digits, but they're the same thing. You can turn one to the other and vice versa. So if you take a Dell service tag, you can get an Express ID, you can look at the warranty for it, you can do all that kind of fun stuff. So you have this kind of like Oracle capability, being able to go to the Dell website, look up a given number, and find out when that machine was manufactured, what the specs of it were, all that fun stuff. And since it's a numeric number, you can just add 1 to it, or 2, and figure out what else is there. How many machines did, take the German tank problem, but apply it to you got a Dell, and see how it basically pans out. So, one example here is like 38 billion is a number, so the space isn't really that big. So these identifiers often include the category, the sequence numbers, some of them include checksums. Social security numbers are a good example of that. Credit card numbers have what's called the LUN check, which is just the normal digit check. But vehicle identification numbers are actually another good example of that. So if you look at a VIN, it's got a bunch of little digits here. You've got 1, HG, B4, et cetera. But every little part of the VIN code tells you something different about the car. And the interesting part is the last 6 digits are the serial number of the car, and you can never have more than 1 million cars manufactured of the same type in the same factory in the same year, because they just won't fit in the VIN. You have to come up with a different code for it. So this tells you a little bit about like the physical space. Like you're never going to make this many cars. You're never going to have that many people. You're never going to have that many cards issued. You're never going to have that many session IDs. So you kind of see where this is going. IDs tell you a lot about the location, the time of creation, and the rate of change. The more samples you have, the more information you have about what's happening with it. So they often represent like a real-world physical limit. Like you're not going to have more than X number of people born at a given location in a given year, or at least you're going to have kind of a logarithmic range of where that's going to be. And even a small sample can help you define the overall range. With the German tank problem, you only need about like 30 or 40 samples to get a really good bead on a number between like 1 and 10,000. So why does all this stuff matter? Well, as probably you guys know, like missing ACLs are not just for the web. Like we use sequential identifiers all over the place, and there's a really common security problem where you just don't check the authentication, and if someone knows the right ID, they can just look it up. But it's not just websites that do that. It's everything from like phone systems. It's all over the board. And if you're able to identify someone's number or ID, you can then abuse it and do terrible things with it. So one of my fun, I would say favorite, but it was only this year, Walgreens. So Walgreens is the pharmacy I go to. They sell me lots of drugs. It's great. If you look at the prescription number you have in your bottle, though, there's a 7-digit number followed by dash and a 5-digit number. It's like, this is pretty good. It's pretty secure, right? Well, except for the 5-digit number is static. That never changes. That's basically your store ID. So if you're down in South Lamar, it's 1933 all the time. It's 01933. That's the only number you get. And the next one down the street is 1934. So now you're down to 7 digits. Well, what if you get 2 prescriptions filled back to back? Well, are they, do you get 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 8? Yes, you actually do. They're allocated sequentially by store. So you've got a really tiny window range. So if you fill 1 prescription on week 1, another prescription on week 2, you can just look at the bottle and say, they've only filled 100 prescriptions between now and then. So you know exactly how many prescriptions that Walgreens is filling. What's worse, though, is that if you take your prescription number and just change the number by 1 and go to the website, and until about 6 months ago, they would just tell you someone else's prescription. Now, in the web UI, they would say, oh, you're getting your treatment for gonorrhea. Here's your thing that you're buying, right? But in the web request in the back end, that actually give you the name of the person too. So they wouldn't show it to you, but it was actually in the XHR response coming back was the full name. So this is one of those things where I'm not going to go any near this with a 10-foot pole with my real name, right? So I called a friend of mine who works at DHS. I'm like, you report it to them. I don't want to get arrested. So he went and reported it. They fixed it and things like that. But it's not like they changed the sequence number. It's still the same sequence number. You still have a really good information link about how many prescriptions are being filled, the store ID, all this great stuff coming off the label. Another fun example, which is a little more trivial, is Chipotle. Like, you want to go root around the Chipotle trash can for 5 minutes in the morning and pull a receipt out, then come back at lunch and pull another receipt out. You know how many burritos they sell, because all the order numbers are sequential across the board. As a friend of mine used to say during the pandemic, like, I didn't realize they gave you all that free food at McDonald's. You just walk up and grab it off the shelf there. It's amazing. But it gives you an idea. If you're trying to guess an order number, if you're trying to figure out what the frequency of a business is, it's all on the receipt. Everything from the store ID, the order ID, when it was made, the timestamp. Like, it's a pretty precise measurement that you get just from a single receipt. And you're being handed this stuff all the time. You're getting all these cool little samples of data being handed to you. So this stuff is less relevant for kind of day-to-day consumer stuff, even though it's kind of funny. But if you want to start, let's say making money from that, you go look at like a popular web commerce platform and say, hey, this web commerce platform, every time someone creates another order, it increments this global order ID in a certain way. In this case, Oracle Commerce is a very common platform used by a bunch of large public companies that are very consumer-oriented and trade based on their business volume. So for fun, I went and grabbed all the basic order IDs from these companies over about 2 months in this case, back in 2015, and then mapped that to their share prices and looked at their earnings forecast and all that kind of fun stuff, and could literally tell you like how well their business was doing just based on how quickly they were generating new order IDs in the back end. And it was pretty spot on, like managed to nail it pretty quickly. Like there's a nice little spike here that correlated with them saying, yes, we hit our numbers, and this was, cat shop, flower shop, jewelry shop. You can imagine what big retailers they were. But yeah, so there's these information leaks can actually be pretty useful. Now, I'm not like a quant trader, so I just lose money if I try to trade on it. But at the same time, like, it's kind of fun to see, like, be able to map this stuff out and be able to track it in real time and then be confirmed by the earnings reports. So going back to security again. Knowing how identifiers are being allocated is critical to being able to figure out whether it's predictable. If it's predictable, obviously you can attack someone else, if especially the ACL's not in place. But it's not really obvious. So looking at this number, anyone have an example offhand of what they think this number encodes? It's hexadecimal. 67, that's like, lowercase ABC, 7, like EF or something like that. You got a few other digits, then they're kind of all over the map, right? So it could be anything. It's a 64-bit number. It's got a bunch of bits to it. Well, ends up if you just lop off the first 32 bits and then turn that into a timestamp, it's actually October 21st. So you know exactly what it is. It's this particular timestamp. And these 64-bit IDs are all over the place, especially in JavaScript land, right? Because you use like the, not nanosecond, but millisecond times 1,000, whatever it is, I guess nanosecond precision everywhere. So another example would be like a UID. UIDs typically look like they're random. They got lots of bits. They look like they're random. This looks safe and secure, right? All good. But no, actually, this is actually a SQL Server ID that's been encoded, and they flip some bits around. So even though it doesn't look like a v4 UID, it actually is a v4 UID. It's just that SQL Server does some byte frobbing on it to turn it this way around. So another example of a UID. So this one looks like, again, pretty random, not a lot of stuff going on. Just at first glance, has anyone seen any problems with this ID? So usually with the UIDs, you can tell what version it is because you'll look for like the the first number in the second and the third group will tell you the version of the ID. So this is the UID version 1. The fun thing about UID version 1, though, is it actually encodes your MAC address into it. So anytime you generate a UID v1, you're literally MySQL to this date, if you call the UID function, will stick the MAC address for your server into the ID number, and then you turn around and give that to your customer, right? So you're sticking your MAC address and all kinds of things. You probably don't want everyone knowing your MAC address and the exact time and date of creation. So if someone goes to your website and you allocate them a random UID through the MySQL UID create function, and then they come back a month later and you give them a different UID, they know exactly how many users you've allocated to now and then. You've just given away your entire business intelligence to some Yahoo because you used the function that's the default. And this is pretty standard. So this UID is actually one I ripped out of the Windows registry, where someone created a comm control at Microsoft in 1998. And they were doing it on a Dell, and their Dell's MAC address got encoded to this comm control and put into the Windows registry forever. So if you're trying to discover IDs, there's lots of fun ways to do it. So you generally need like some kind of sample ID to work from. You need an action to resolve an ID to some sort of attributes. Like, how do you know what ID looks up to? Can you query the Dell website? Can you query a Mac lookup table? And you need some way to like record the results and correlate attributes. So I grew up being a hoodlum here in town, and so what I did for fun is I just call random phone lines and write down what I found. And so I get my grid paper out and I start like dialing random area codes and figure out which ones are modems and phone, voice systems, things like that back in the 80s and 90s. And you get a big piece of grid paper. You got 000-999. You start calling and linking it all together, and so you get your modem out and make it a little bit faster. So you got 10,000 numbers in a given block. So assume this is 512.454, and this is pre-TCPA, which made word dialing illegal. So I know it's a felony now. And you start calling. So you start dialing. Every call takes about 30 seconds. This takes a very long time. You're sitting there just dialing on your modem for hours, and your mom's going to wake up soon and take away your phone. So you got to dial pretty quick. So it's about 83 hours of dial every line. But as you start dialing, you start seeing these patterns appear. So you're kind of playing Battleship in a lot of ways. You're saying like, how about 34 or 0004? So you start seeing like lines here. So you're the top bright green line here, these are all the old modem blocks at IBM when IBM had this range. The red blocks here are a series of numbers from the local Southwestern Bell that would always return a busy signal when you call them. Empty blocks are always the ones where no one picks up. It just rings out forever, called the ring out. And then you've got other dots here. Some are voice, some are fax, some are people, things like that. The gray ones are voice. That's what there's so many of them. But you start getting a really idea of like how is the whole telephone system laid out just by being able to dial enough numbers. And you don't have to call all 10,000 and start figuring out the patterns. You can really start kind of working backwards here at different intervals of it. And this is me showing off some dumb view component I wrote in JavaScript that actually draws it all in D3 in real time. So, but the idea is like the backend data for this is actually generated by Go, which is the one of the Go parts. This is taking ancient word dialing from 1998, scanning all the files, generating a bunch of the D3 maps out of it, and spitting it back out into JavaScript for this presentation. Let's see. So, that's phone numbers. Phone numbers are pretty straightforward. You got 10 digits in the US. What about IPv4 addresses? So IPv4 is a 32-bit number. It's, 32-bit, 4.2 billion possible range of IPs, only about 3.7 billion are really allocated. Of those, only about 2.5 billion are really in use. So if you want to go through and try to figure out like what's in an IP range, this is a really fun, easy way to do it. So let's say we'll just take a /24, like 192.168.0.0/24. The very top part of the grid, 000, bottom right, 255, and we start going through and pinging stuff to see what's there. So, pinging IP doesn't take very long at all, really quick. You get a really good sense for what's being mapped. So we see an address at .1, we see an address at 10 through 15, another block at 20 through 25. Things are kind of scattered around 128 or so, and then you have another block down there at 240 to 246. This is kind of a standard network layout. You often see administrators will put the important stuff, the lower addresses and the higher addresses. Then you see them have DHCP ranges kind of set up in the middle. Those are ones that kind of dynamically allocated to guest users, things like that. But just knowing whether the IP is alive or not doesn't really tell you very much. What are these IPs actually are? So let's turn around, scan it with Nmap and get a better sense of what the device type is. So again, if we start to classify the IPs based on what type of device it is it a router, switch, server, printer, endpoint, whatever, you get really clear patterns. You see all your endpoint Windows desktops are here in pink in the middle. The bottom right, you got a bunch of cameras. Top left, you got your router. Little green guys are the different access switches for each different network, and then you got your servers in the upper right. So this tells you really quickly that, hey, if I'm going to go after your Windows desktops, I'm going to go hit the machines in the middle. If I'm going to go after your servers and go after the ones kind of the first, the lower bounds of the range. And then a fun hacky thing is this whole thing is generated by Go, of course, and it spits out a mermaid.js file, which is then rendered into this particular chart. So this chart's actually just a mermaid chart. It's just a bunch of mermaid grids smashed together in a particular Mermaid.js is like kind of a markdown graph rendering component you can use in GitHub. So this whole thing will actually render natively in GitHub if you want, just by pasting it out. So I recommend using Go to generate mermaid graphs to spit into markdown. But all right, so if you start scaling that out, so like instead of looking at like a little /24, let's zoom out a bit. Let's look at like a large enterprise like /16. So 655, 36 possible addresses. How are those laid out? We see very similar patterns. On the far left side, all those blue ones, those are all your Cisco routers. They were your .0, .1, .2, .3, .4. Then you see things kind of broken up almost by horizontal stripe. So in this case, unlike phone numbers, where we're using powers of 10, like 000, 100, 200, 300. In this case, we're using powers of 2 because IP networks are on powers of 2. So you'll have .0, then basically the 255 in the bottom right, and everything here is allocated as 256 per line across. And you get a pretty good sense for like where your workstations are, your printers, your devices, where things look more the same, where they're more mixed up, where they're empty. And this also helps you as like an attacker going after and finding stuff. Another fun example is when you start doing this at scale, you start looking at like really big subnets. Like in this case, I think this is like Belarus somewhere, some big broadband, home broadband segment from Belarus. When you start zooming out, you start seeing a really weird pattern. And depending on which picture you're looking at, how far away you are, you can probably see this better or not. But it looks stripy. Why does it look stripy? Why aren't the stripes vertical? Why are they like this? Like, that doesn't make any sense at all. So any ideas for why an ISP would make their IPs go like this, not like that? For some reason, this ISP staggers the DHCP ranges by like 2 or 3 per subnet. So as you're going down, they start allocating a different spot, and then you have this weird kind of pattern showing up. But you'd never see that pattern if you looked at a single subnet. You'd only see it if you looked at like a much, much bigger range. So the idea is like if you're sampling an IP space, you want to get as far back of a zoom as you can, because that's where you start to see really, really interesting patterns that pop out that will not show up otherwise. I don't know if you've ever seen like the global ping graphs like this before, but effectively every graph of internet attack traffic or IP address stuff, it's just a population graph. That's it. Like if there's people there, you got, oh, and the screen died on me. Let me try reconnecting real quick. And we're back, okay. Cool. So basically, like most maps like this are effectively just population graphs because there's not people in most places of the world. When there are people, they do network stuff, therefore that's where the bits are. Has anyone here seen a Hilbert graph before? So the difference between like this graph, of course, is geographical. A Hilbert graph is a way to map numbers that they're closest to each other. So you want to make all the numbers that are sequentially be as close together as they can, on a 2D grid as possible. So they kind of do like a little like, almost like a little spiral walk in a lot of ways. So the top left here is like 100/8. They're all kind of clustered together. This is actually before Cloudflare negotiated for the 1.1.1.1 address, before the whole long story there. But effectively, anytime you use the Cloudflare DNS server, you're also giving all your traffic to APNIC as part of the agreement, which then turns around and gives all your traffic to CNNIC, which is the Chinese Communist Party, and they see all your traffic, which is why Cloudflare invented encrypted DNS so quickly. So to be able to get that address, they had to share the data. To share the data, they didn't want to share the information, so that's why they pushed encrypted DNS so much as a result. But that's the backstory there. But so this is basically the entire IPv4 internet. The big top right graph here is your reserve space, like your 224s, all that stuff up there in the corner. That's all pretty empty. And the rest of the space is pretty randomly allocated. The top left grid, if you see that little white box, that's actually zoomed in here to the right side. And as you start zooming further and further in, you start seeing this big block of red IPs for some reason. And ends up this block of red IPs is all systems that respond to voice over IP SIP request. And it's all in Germany. So why does like every broadband IP in Germany have a SIP endpoint and respond to voice over IP requests? Well, that's their telephone system. Their ISPs literally give every home user a Fritz box that registers SIP endpoints, and you can make voice calls to someone's home IP directly through their broadband modem like that. Like that's just how their telecom infrastructure works for home users, which is pretty cool. So as you start going through it, you can see like there's definitely patterns that pop out in a Hilbert graph that don't show up on a sequential graph, and vice versa. But if we wanted to start digging into V4 a little bit, we talked to some folks earlier about Shodan a little bit. So you've got 3.7 billion of 4.3 billion is actually routable IP v4 space. About 774 million of that is already in Shodan. Literally, Shodan is a Shodan.io, great website where they are a service where they go through and they scan the whole internet continuously, and they do so much discovery of the internet that literally about 20% of the entire internet has a record in Shodan at this given point. If you just open up a command prompt and type ping in any random IP address that's in an allocated range, you got a 17% chance of getting a response right now. That's how busy it is. Like, we've gone from the IPv4 address space being this like big murky ocean that we can't see into to being a really tiny fishbowl that we're all, there's a million threat actors all doing stuff all the time and kind of in real time where we're all watching. And it's become a very small space as the population of internet users has increased. So keep in mind, there's only 3.7 billion routable, about 2.5 billion in use. There's about 8 billion people. And depending on where you are in the world, like in the US, you get about 10 IPs per capita here. But if you're in Asia, you probably get 0.1. You go through CGNAT to get anywhere with your mobile phone provider. So it really depends on where you are, how IP rich you are in that sense. Now, if you go the other direction and look at IPv6, it's the opposite. IPv6 space is like unfathomably huge. And I say unfathomably because you literally, like, there's more grains of sand in the universe than there are there's more IPv6 than grains of sand, right? As you start zooming in, so first the graph on the left, we're going to zoom into this tiny little block over here, which is actually the reserved space. And then we start seeing this tiny little, like, itty-bitty little corner here. We zoom into that. And now you're starting to get into the actual allocated space. So you get to, like, multiple magnitudes of zooming before you even get to, like, a range you can pick out from more than 5 feet away. So interesting about that is you can't scan anymore. You can't just say, like, I want to go start at 1 and go to 1,000,000 because you're never going to find an IP there. So range-based discovery doesn't work. So, an example of that, if you're trying to figure out, like, where's your computer in IPv6? It's way down here somewhere. There's your computer. And good luck finding it otherwise, right? Because it's just massive amount of space to go hunt for it. And that's very different from v4. However, on a local network, so let's start off with every person in this room who has a phone has a v6 address, at least one right now on your phone. And if you have a current connection to the internet, you probably have at least 2. If you look at any laptop machine you have, you probably have at least 1 v6 address, maybe 2, maybe 3, depending on where you are. So we don't really think about IPv6, but it's literally everywhere. So the really cool thing about v6 versus v4 is v4 doesn't really tell the rest of the network about itself by default. You get the ARP request, things like that. You don't have a lot of broadcasting. You don't like announce yourself as much besides the DHCP request in v4. But v6, it's trivial to discover every v6 system on the same local network. So if you just type ping 6 ffo2 : 1 $, and your MAC address, your Ethernet interface name, like EN0 or Wi-Fi 0, whatever it happens to be, you'll get a response back from everything in the local segment. And if you do a few more tricks, you actually get responses back from devices that aren't supposed to give you a response back. You can send SYN requests and UDP probes and all kinds of other fun stuff. There's even a fun mode where you can send your DNS request to the local v6 broadcast and get a reply from any local DNS server that happens to be replying faster. So any kind of DNS caching hack, if you will. So v6 discovery is trivial if you're on the same local network, but it's nearly impossible to find otherwise. So there's a research group that put together this thing called the IPv6 hit list, where they tried to predict how people were allocating numbers. Now remember, going back to the PIN numbers, if people are allowed to choose what numbers they have, they choose poorly. And so v6 is no exception to that. When a server admin gets handed a v6 range, instead of picking like a random number out of that range, because literally every machine in v6 gets allocated the internet times the internet of v4 addresses for its own IP. So your phone will have a /64 assigned to it, which is like 4 billion squared. But server admins don't want to deal with that crap. They want to be able to predict where their IPs are. So they typically will take their prefix, and then either encode their v4 address into the end of it, or they'll pick like 001, or 2, or 3, or 4, or whatnot. So the IPv6 hit list folks figured this out, and they started building an algorithm to predict what IPs people were allocating that way, and building out a machine learning algorithm to predict IPv6 space. And they thought they were super cool, right? They were like, okay, we now predict 2.5 billion IPs. Of those, let's see if we got a graph for it. Yeah, they basically found about 20 million or so live IPv6 addresses using this kind of predictive model of guessing numbers in the v6 space of 128 bits, which is like winning the lottery repeatedly, right? It's a really hard thing to do. And then Shodan kicked their ass. So Shodan, who's run by a gentleman named John Matherly, who's actually local to Austin, they scan the whole internet. And they've got 211 million IPv6 addresses in the Shodan database at a given time. And everyone's like, how the hell did you do that? Like, even this like research group that's spent the last 15 years on it has only found 20 million live IPs. What are you guys doing? Well, they have a trick. They are a provider of time service. So they registered as many machines as they possibly could into the ntp.org time pool for NTP. And so anytime you have a machine that has a v6 address and it asks what time of the day it is, it ends up asking ntp.org for an IP. Eventually, you'll hit one of Shodan's servers. And Shodan will give you the time. And everyone got mad about it and pissed off about it a few years back, said, what the hell, you're leaking off. But not only will they give you the time, Shodan will then scan you. So as soon as you ask them for the time, they will then scan you and put you in this database on the internet, which is freaking hilarious. And the best part is when they got called out for it, been like, dude, this is sketchy, you're scanning us. He's like, yes, but you got the time. So I love it. I love his really creative approach to doing V6 discovery, where he's like kicked everyone else's butt on doing V6 discovery by making people come to him instead. So kudos on that. So a different 128-bit identifier that we talked about earlier is UIDs. So you see UIDs everywhere. Or they're called GUIDs in Windows or UIDs, and you see them in like database identifiers, things like that. They look randomish. They're about the same length as a v4 address with a couple bits flipped here and there for the versioning, things like that. But they often have like richly encoded data in them. So if you ever see a list of UIDs, the main thing you want to look for is the third set of numbers, the first digit of the version. So just skim that as quickly as you can. Number 1 means it's got a MAC address. 2, it's got a MAC in it. 3, it's got a timestamp. 5, it's got a timestamp. 4 is random. 6 is a timestamp, 7 is a timestamp, and 8 is pretty much user defined, but often random as well. So depending on which version you have, you're almost always going to see either version 1 or version 4, and very little else. At least until very recently, nobody used anything else than version 1 and version 4. So if you're trying to get UIDs to play with, you can set up a web proxy like Zap Proxy or Burp Suite and basically record all the web requests, that stuff. What I like doing is, what I spent this whole weekend doing was harvesting Word documents from the ages of the internet. So wrote a bunch of code to go grab basically search for Word documents like .doc, .docx, PPT, et cetera, across the whole internet, and made about a terabyte of doc files, which was as fun as it sounds, and then scan them all to rip out all the UIDs and then mapped all those out. So that's part of some follow-on work that's kind of in progress. I also took my Windows 11 machine, dumped its entire registry and all its binaries out, and then scraped all those binaries to rip every UID out of those, see how those are allocated. And then, of course, you've got database record IDs. When you're building a web app and you use a UID as a column, you can use those too. So once you have an ID, what do you actually do with it, right? Well, you can decode it a little bit. There's a decoder plugin for Burp Suite, which is a little bit out of date, doesn't know about V7s yet. But looking at just the Windows registry, for example, you can see that Intel Corporation is the #1 MAC address provider of V1 encoded UIDs. So the early Microsoft developers used mostly Intel network cards, as well as Dell. And then there's Digital Equipment, but that one's actually explainable because that's actually the company that created the UID format and the COM IDs in the first place. So those are actually like the original OG UIDs are from DEC. And then Toshiba has a little bit there. The one that got me though early on is like, why is 3Com there? Like 3Com doesn't even make computers. Why are so many freaking UIDs associated with 3Com? It totally like missed me that 3Com used to make network cards, and network cards are where the Macs come from. So even though it wasn't until recently that your MAC address was associated with your system vendor, like Apple, Dell, et cetera, it used to be you get your computer for one person, your network card for somebody else, and the network card, like 3Com, is where your IDs actually came from. So it's kind of cool to see that in practice. Going back to the doc stuff, I haven't done the full analysis of the document files yet, but I don't know if you remember back in like the late 90s and early 2000s, people would say like, the NSA is spying on you. If you have an Office document, they know where you're coming from and they can track it, where you've been. It's true. It's really cool. So we went and like proved it out. Went and dumped all the MAC addresses encoded into documents from the 1990s through early 2003 or so when they stopped using UID v1, and then looked for. The nice thing about Word documents, you also get the metadata. You get the author name, email address, all that fun stuff. So I took like all the documents from nih.gov and found all the researchers who did that. And you can chart when they got new computers. You can see when this particular researcher actually got an upgraded computer. It's like, oh, you got a Dell, good you, check you out. You actually got a fancy computer after 4 years, you poor government employee. But it's really neat to see that in real time. So the cool thing about that is once you have the MAC address, you can then look in all kinds of other places for that MAC address. Any other place that MAC gets leaked back out, you can then correlate it back. You want to go find like that person's computer on eBay, you can build a scraping algorithm to go find the MAC address in the picture and do all that fun stuff. So there's a gentleman who did a really good DEF CON talk this year where he built a image recognition system to look for proprietary labels on systems being sold on eBay and then bought them all. And then dumped all the hard drives, did terrible things with them. So he had like all these like prototype iPhones, things like that. They found ways to basically bypass authentication, dump all kinds of fun old tooling and product factory codes off of them. So I'm not that cool, but I thought it'd be fun to go through and do the same thing for like MAC addresses. That's kind of where this stuff came out of. All right, so taking a step back a little bit. For anyone here who does database work all the time, one thing that's really not fun about UID v4s is that there's no prefix on them. They don't get allocated by time. So if you're trying to partition your database tables appropriately, UID v4 is actually terrible for it because the beginning of the prefix is always random. So you're not going to get like any kind of data locality based on timestamp. If you want to create partitioning on that, for example, it's not a great partition key because it's random on the prefix. So The fix for that is something called UID v7, which puts a 48-bit timestamp in the first few bytes of your UID, and then the rest of it's basically random. So you lose a lot of your randomness, but you also get a nice locality timestamp prefix in your UID. So expect to see that everywhere soon. But again, what's the downside of using a UID v7? You're now telling every person that you give a UID to when it was created. You've now embedded a timestamp for them too, not just you. So keep in mind, whenever someone starts starts embedding information into their identifiers, you're giving it not just their development team, but also everybody else who sees that. And so you start leaking business data immediately. So MAC addresses are fun. A lot of folks realize that the first 3 bytes of a MAC address tell you like who the vendor is, but it's not just the first 3. It's actually, there's different sizes of MAC allocations. There's the first 3 bytes, first 3.5 bytes, first 4.5 bytes. Those are all actually ranges you can allocate. So what's interesting about that is like over the years, companies started off buying these 3-byte prefixes and then they ran out. So if you're Microsoft, for example, and you hate me, what you'll do is you'll take all your old Xboxes and you'll reassign the MAC addresses to your Surface laptops. So when I go through and try to write fingerprint for my company product, we start fingerprinting all the bank tellers machines as being Xboxes, and the customer gets really confused. Well, because they recycled the MAC range. So Cisco is also notorious for recycling MAC ranges. They stopped doing it, but for the most part in the last 4 or 5 years, what you've seen instead is that companies now buy smaller ranges at a time. Instead of spending X $1,000 for a big range, they spend a smaller number for a small range, and they keep buying more small ranges as they need them. The really cool thing about that is they're now leaking when they bought that range. So that range is allocated, they pay for it, and then they fill out the range pretty quickly, then they buy the next range. So effectively, you're embedding the manufacturing date into the device's information based on its MAC prefix. So as long as you know when that MAC prefix was allocated, you know a general idea of how old that device is, which is a really cool thing you can do. So one of my Go projects is MAC age tracking. So we scrape the IEEE database every day. We keep track of all the stuff. We go back about 20 years. We can tell you how old a particular machine is based on the MAC address. So MAC age is the project here. IEEE also records the owner and the address changes, and we track that too. So we can tell you like when a MAC was reassigned, when a company changed names, when their address changed, things like that. So like in this case, 3024B is a Huawei manufactured in 2024, October 23rd. So you actually get really precise timing. You actually know when someone's about to ship new products, so they buy a bunch of new ranges. So you get predictive value, and you get kind of like look back value in terms of how many devices they ship in a given time frame based on how many MACs they had to allocate. One of the exceptions to this is Amazon, because they also hate everyone. They will allocate sequential MACs in a row that are completely different devices. You'll have a Fire Stick with 01, you'll have a freaking TV with 02, you have like an Echo device with 03, and literally we have enough MAC address data at work that we can see that happen. You start looking at sequential allocations, and literally Amazon will just allocate back-to-back totally different devices in the same range. And that's one of the very few vendors that does it. Usually when they allocate a range, you know what type of device is just based on kind of where it is in that sequence. Anyway, so if you want to like, let's say data mine Macs, you can go scan the whole internet. So part of what I do for fun is they'll scan the whole internet and query SNP, MDNet, NetBIOS, all this other stuff to get MAC addresses and make a big grid out of it, stare at that for a while, figure out how they map, things like that. But one of the fun things I saw coming across the wire was this really weird traffic in port 987 and then later on in 9302, and it looked like SRCH star HTTP. So it's kind of discovery, it's kind of plain text, it's kind of HTTP, but what the hell is it, right? So, like any normal hacker type human, I would just, instead of trying to figure out what it was, I was just lazy. I'm just going to take their packet, turn around and send it out to the whole internet too and see what comes back. So the great thing about that technique is anytime hackers come up with cool techniques and they want to figure out what's affected by it, they give you their technique, and then you take their technique, and then you do the same thing with it, and then you scoop them on the research. It's great. So hackers don't like each other very much, but it's a lot of fun to be able to like know about someone's research before they go public with it, because you've been watching them do the research and then finding your own results ahead of them. And this is one example of that. So it ends up all these devices are actually PlayStation discovery packets. So you can scan the internet and find all these PlayStations on the internet. Well, who would set up their PlayStation on a bare public IP address, right? It doesn't make any sense at all. Well, the answer is nobody, but it happens anyways because your PlayStation will cut a hole in the firewall and allow itself through UPnP. So the same problem you have with like the Huawei, the Hikvision, the Dahua cameras is that they'll automatically carve holes in the UPnP firewall configurations to allow inbound traffic from the internet just for fun. So you can like play games with other people, but also expose the discovery protocol. So as a result, you can scan the internet repeatedly for people's PS4s and PS5s, and you get all kinds of cool data back. You get like this thing called an ID, which is just the MAC address. You get the name, which tells you the sequence number. You get a protocol version. You get some version number of the system firmware to see how old the firmware is. But the most fun part about all the scores, you also get the manufacturing date, so you can see how old their PS4 or PS5 is. But you also get to see what they're playing. So this is the fun part. So I was just scraping the internet for weeks, watching what everyone playing different games on PS4 and PS5. And funny enough, the most popular application, if you're going to buy a PS4, you're mostly going to use it to watch YouTube. That is the most popular thing people play on PS4. And then Netflix, then Call of Duty, then Fortnite, the Prime Video, and so on, so on, so on. Then you start getting some of like I didn't translate some of these names, but Red Dead Redemption, Overwatch, things like that. You'll see a pretty long tail of firmware versions. So of course there's a million devices on 43,000 with this firmware version, 33,000 this one, then a long tail of ones that never upgraded. So yeah, kind of fun to do. Anyways, short version of this is like, IDs are fun. You should look out for them. Short IDs have lots of information in them. Long IDs, even though they're not sequential, they give you really precise tracking information, and there's data everywhere. Have fun. So that's the doc. Thank you very much. So most of the scanning tools, most of the data analysis, that was all Go stuff. So I'm happy to talk about doing like raw packet stuff. At work, we do we send raw IP traffic, UDP, TCP, ICMP, all kinds of fun stuff. But we don't use libpcap because that's for noobs, and we don't like cross-compiling crap with Cgo because Cgo is terrible. So we end up doing our own raw dev BPF and raw socket stuff for writing packets. So if you want to talk about like writing raw packets without using Cgo or libpcap, like I'm happy to chat about it forever. Same thing with like large-scale data analysis or scanning and Go. That's kind of what I do for fun all the time. But any questions on the talk or in general? Awesome, thank you. I think hopefully Charlie will be here at Pizza. Oh, yes, sir.
Actually, I've been curious about Texas license plates because it's 3 letters, but not all the letters, and then 4 numbers. They seem to all go sequential. That's not very many license plates. What? I don't know. You just piqued my interest. Are they recycling them? Are they? What happens when you sell a car? Don't you have to? Do you have to get a new license plate or no?
So the license plate, good question. If you look at it, there's only room for 7 digits, right? Or in some cases, I think you can get a plate with 8, but it has to be like one of the special plates, and it's going to have a hard-coded prefix on it. Another fun thing with Texas plates is little symbols actually don't count as anything. So you see like a star or a dot, they're actually not part of the plate number at all. So if you have like I've got a plate that says I love shells from Metasploit, because that would be funny as hell because I love remote shells on other people's computers. So it was I heart shells, but the heart doesn't actually count as it. So the license plate number is just I shells. And everyone thought it was really weird. So like, this guy really likes seashells, I guess, So I've got another plate on a car I sold that's calc.exe. So same thing, dumb hacker joke, but the dot doesn't count. But the funny thing about those is the number plates get recycled the second that you don't register them again. So every year that goes by, if you are not the new registration owner of the car, then you don't get the license plate. License plate goes back in the pool again. So that applies to custom plates and applies to the randomized plates. So you can have 20 people with the same license plate as long as they're on different years of registration and they didn't own the same car at the same time. And typically when you buy a car, you'll get a new plate for it, and then we'll basically retire the old plate number for it unless you reassign it to your car. But I buy too many stupid plates. What's that?
Aren't they sequential at first?
Just sort of. Like, they're not like sequential in the normal sense. They probably, because they randomize the first 3 digits a little bit, of the characters. So they don't actually allocate them as like, ABC 001, 002, 003. It looks like instead what they do is they fraud the first 3 bytes a little bit. They pick a random one out of the bucket, then do that again. So there probably were some years that they're allocated sequentially, but the ones in like, if you really want to dig in.
They don't allocate them sequentially anymore. They do before.
No, I don't think, not anymore. There are some ones they still allocate sequentially, like state officials, for example. Those have the little short, like 4-digit numbers, like SO dash whatever. Those are definitely sequential. But most of your standard 3x4 plates are not sequential anymore. And you can prove that by going to the Texas smog check website for safety inspections. All their IDs are sequential. And they're not authenticated, so you can pull up everyone's reports and then just data mine those, and you get everyone's plate numbers, and you know what smog place they went to get their stuff checked, and then you have a general idea of where they live. So, yeah.
So if you can have multiple plates, this is totally a rabbit trail. I don't know if you want to keep going. If you have multiple plates with the same, what are the cops doing to uniquely identify a car? Do they need the plate and the make and the model and the?
There's only one plate at a given time so only one plate's allocated to a given person at a given time.
Yeah, but if I stop registering my car.
Oh yeah, they'll think you're the other person. You can just go down a toll lane all day long and mess with them. It's great. Yeah. So yeah, they will give the other person the bill for sure.
Wow. Okay.
I mean, eventually they'll like pull up the camera and pictures and see you laughing as you drive through, and they'll do like face recognition on that or whatever. But yeah, they just look at that based on who's currently registered to that plate number, and the plate number expires when you're no longer registering it that year.
Wait, so if you want to renew, but like if you want to renew late, don't they let you renew late? Like you're gonna have a different plate if you renew late, or how does it work?
I don't know. The longest I've ever gone without renewing my registration was 8 years. Yeah, I don't know if you guys ever saw the Seinfeld skit where they're like test driving cars and they decide to like drive. They're like, "Hey, you're out of gas." Like, "No, I'm not out of gas. We're gonna believe in this. We're gonna just keep going, right?" I did that for like 8 years with the car without registering it to see if I get pulled over or not. Because after 2 years, it's actually break even in terms of they can't charge anymore for it. So if you get past 2 years, I mean, that's it. So. And these days it's actually worse because if you have an electric car, they charge you like $300 a year now. It used to be $80 a year for a gas car because they're not getting their gas tax from you. So because you're not paying the gas tax at the pump, they have to charge you more for the registration to make up for it. But it means there's a even higher incentive never to register your car again. So if you make it more than like 1 year now, it's actually net even not to ever register your car again. So they didn't make really good incentives for that.
Did you register it after 8 years, or?
I don't know. I didn't get pulled over. So, I mean, it never really. But I also didn't have a license for like 5 years and didn't realize it till they pulled me over and said, "You don't have a license." "Yeah, it's right here." It's like, "No, we canceled it." I'm like, "But it's right here." So yeah, it's the reality takes a while to catch up sometimes.
So I think like technically are you still covered by the insurance if your plate is invalid?
Yeah, the insurance doesn't care. They register the vehicle based on the VIN number. They don't care what plate you have.
In Florida, they cancel your license if you haven't registered your car. So
Oh, okay.
one time I changed things from Florida to Texas. They sent me a letter. "Hey, you want to cancel? Like you're gonna have suspended license." It's like, "Wait, no." So they have to like resend them back. Like, so they have maybe a better system.
Okay, that's smart. So they made you like physically send the plate back to.
Yeah.
Oh, okay. I just got a giant pile of plates. Okay. I keep them as souvenirs now because I buy like stupid plates for work and then I just keep them on the wall after I sell the car or whatever. But you can also use them to go through the toll lane too. It's still probably safer than little paper plates, right? So, cool. Let's see. Let me get up a little HXGO. Is Charles back yet? He may be actually making our pizzas personally at this point. He seems very invested in the outcome. Thanks.
Is the store of MAC addresses that you've scraped over time, is that like accessible more widely or no? Okay.
I'm happy to share it though.
Okay.
So I haven't like posted like, so the scrape ones, most of the ones, so the Word document ones I haven't published anywhere yet because they're all just local to my laptop right now. They're right there though if you want a copy. I got about like at least 80 gigs of Word documents on that laptop. The rest are on the home server, but
Fair.
yeah.
Oh, yeah, that reminds me. I did have a
we're gonna safely delete all these intelligence documents and exploits we got. But then they got hacked, but the FSB stole the documents from them. So then the Russian still, like the Russian intelligence agency still got it, even though it's first we intentionally like tried not to give it to them. They got hacked by their own government. So that's something might be a problem. Yeah. This is not an elevator. Unused, password keyboard. just here. Not much. But it's fine. At this time, what I want to do here, put on the ground, doing my startup. And right now we are looking for jobs because we are exactly in the right spot to deploy. At the very beginning of the year, we start getting some financing, so we need to really fast to start going down to. So what we are doing, we are helping the long-term companies, so we are in the beauty industry. We are helping these guys streamline operations, with productivity, profitability. Long story short, this is an actionable implementation regarding the right product, the right rate, the right timing, and the right way to do it right. When I say product, I mean fertilizer, suitable pest control, food balancing product, and water. And from there we go further into the financial analytics, the company performance, and so on. Because these guys going to stay in office and do all the work, the wrap-up. They need to stay outside of Rome and do the job that actually pays the bill. So this is what we are doing. We are working with Golang and React on the front end. Right now we have 5 guys back in Romania. Quite a lot of experience on Golang, and we are also my colleagues, and they are from Knoxville, Tennessee, over 35 years experience in the industry. So one of those guys is a chemical engineer that manufactures custom recipes of fertilizers for the big companies like Fox and so on. So that's why there is a lot of knowledge that we utilize and supercharging they have and we make it available for the industry. We have on our team for production 7 products. Both part-time and they do both and working training right now to the residential organization of Florida and now we can talk. What else? I don't know. Any questions? Yeah. Are you trying mostly in the US? Yeah, we're focusing on the US. US is the biggest market in the world. Here in the US it's almost 50% of all the laundry industry. So we are focusing on the B2B right now, to the long-term companies, but on the long term we are looking to expand and to build a community and deliver this to the B2C. So right now, my partner and Marty is shown on the internet as a grass factor, and exactly we branded in Fund Research. There are over 37,000 long-term companies that are following him. We have a private Discord group with over 400 subscribers that are actually sending something every month just to be here and ask a question, want to know, hey, I'm having this problem, what should I do? I've burned this guy's grass. Yeah. Cool. What is the connection to Austin? My connection to Austin. That's a very good question. So I arrived here this spring, south of Vermont, and before that I traveled quite a lot in the US. So I started this project back in Romania. Dog agriculture. But when I got to the actual farmers, what they got, because they signed some papers that they have weather stations and everything, and I found out that they had the weather stations in some boxes because they had just to check a box for the government. Hey, I bought a weather station. Give me some governmental grant. And then I was 30%. So when I was invited here by the weather authorities to get one of the conferences and to get the product, jumped to the first level. After that, it was a lot of back and forth, back and forth. So I'm tired of jet lag. The pills don't work like they used to. So I thought, okay, it's time to move here somewhere in the States. And there's a lot of traveling. I find this place very cool. I love the people. I love the city, what the city has to offer. And I love the balance between the city and the nature because we're all looking work, you know what I mean. And at the same time, we're all looking to do different things. So that's quite awesome. Yeah, another reason is that we are part of the international accelerator right now. And they're also having their own record gathering next week for
I'm Nicholas. I'm a infrastructure engineer, so mostly back-end metrics and monitoring, Kubernetes and that kind of stuff, but a lot of stuff in Go for our internal tooling. We wanted a way to have engineers run effectively arbitrary code in production, but in a more constrained way so they can't run arbitrary code in production. So we worked up a thing that we call this runner. You predefine some command that you want to run and in a YAML file and in blah, blah, blah. Kubernetes nonsense. Okay, well, there needs to be a web UI. And so we worked up a web UI. So the service on the back end goes and executes the command and then responds stuff. Well, it needs HTML, and I like Go and not JavaScript. And so I started using this thing called Temple, T-E-M-P-L. Do I need, I can't type in, do this. Do I need this?
It's one stream.
Sorry?
It's for the it's for the streaming.
That's fine. I'll make it work.
Okay, all right.
This is the Temple website if you want to go look. So the idea is that this is a HTML only templating package for Go. So instead of using text template or HTML template or something like that, you use this instead. And the syntax is very much like HTML in Go. So you'll notice I've got, a package declaration and an import, and then I have this special thing, not a func or a var, but a temple. And this is ends up being a function. I'll show it to you in a second. And then you just put your HTML tags in. You can insert data from the Go level in here by putting it inside curly braces. And one of the really nice things is this one. Here's the this is the page, right? So I've got HTML and head and a body, and if I want a for loop, you type it like this. That looks like Go, right? Not like HTML template, which has the weird range first, and yeah, because it's just Go. And it goes until this curly brace, and you can put more HTML inside. It's really nice. So it ends up being that if you have mismatched tags, like you open a I tag and you forget to close it, it's a compile error. You can pass, because these end up being just Go functions, you can pass things into them. You can pass them around. You can make them, as you can see here, methods on a type. And so you can have your, I'm not sure I entirely recommend this, but you could have a type that you read in from the database, and then you call a method on it, and it gives you HTML. You can do loops, and you can do conditions, and you can do a whole bunch of nice stuff. This is the generated HTML. So there's a build step in here where you, sorry, not HTML. This is the generated Go. So you do temple generate, and it reads the .temple files and gives you .go files. So this is, the same logic. It's just got horrible variable names. But it also does things like it's checking for what's it called? Bad stuff getting into your, it's doing sanitization. So if you're gonna just plop a string in, it needs to know that that's safe or not, and it does some of that logic. And there's ways of saying this is okay, it's safe. But it ends up just being like a whole bunch of write string to the buffer and then checking for errors and returning stuff. And it's really quite nice. In addition, by the way, this is what it looks like. Don't complain about my HTML skills there. But so this is just the response from the server in the compiled binary. In this case, I'm also using a thing called HTMX to do a little bit extra. A little bit extra interaction, and I'm using the embed package to pull the HTMX, the JavaScript source, into the binary, so I still have a single statically compiled binary that I can distribute around. It's quite nice. And then I can do things like this. Hey. So this is HTMX doing server sent events that then gets rendered. This is just Go writing bytes to the socket on the front end. Anyway, it's really nice. You can do all the nice normal Go things again, like methods and functions and passing them around and stuff. But you get HTML out of it. It's nice. Cool. So this doesn't do Kubernetes? Okay. Okay, I'll explain it as a database. The arbitrary code that the engineers write, we store that, those like the commands, the shell code, we store that in a database. And then this thing reads the database and lets you say, do it now. But there's no arguments. We don't let you, if you want to pass arguments to the thing, you have to write it into a Git repo and it has to get reviewed. So that's our sort of safeguard on malicious code is like somebody else did a pull request review and yeah, that makes sense and that sort of thing. So this really just reads the database and says, now please, and then shows you logs. Yeah, so like we have a like a data migration in the database. Like it's a script that we need to run, and it's going to do a thing. And so we set it up in the test environment, and they push the button in this UI, and it runs. And they were like, cool, it did the thing right. And then you push the button, the same button, in production, rather than like execing into the pod and then typing some Python, like on a Python REPL. Oh. Yeah, like just write down what you want to happen. You're a coder, right? You write it down and put it in a pull request. Someone will review it, and yeah. And there's one extra part where the infrastructure team, that's me, has to approve the like there is a new thing that I can push the button on. Yeah. As a side effect, there's some nice features like in that declaration thing, you put a date, and after that date, it doesn't work anymore. And if nobody has pushed the button for 90 days, it doesn't work anymore. You have to go in and, yeah. But all that to say, like, the temple, and with HTMX, but temple with other stuff as well is really nice.
Check. Hey, so I wrote a dumb little CLI that turned into a little bit more because Postman made me really mad one day. Also, shout outs to AHA. I already did this there, so if you're there like a year ago, I apologize. Sorry?
So I have no memory of
so sorry. I mean, I might have presented this once upon a time in another life.
You can talk about your talk. He's going to talk about something else. Yeah.
Oh, okay, fair. So, basically, I wish that I knew about tempo at the time that I was writing this because that would have made my life a lot easier. And I can assure you that my HTML and front-end design skills even worse, especially Oh, sick. Thanks. Yeah, it appeals to engineers, a certain brutalist aesthetic. Yeah. So basically, I got hit with the Postman rug pull where they're like, "Hey, do you want to use our cloud account?" And I was like, "Not really." And they're like, "Okay, we're going to delete all your data." And I said, "Never again." So I decided that the only reasonable thing to do was to make a Golang static binary that would live on my system, embed a web UI, and also have a CLI component. Give it a Lua runtime with access to like a small smattering of commands that I needed for my purposes. So I have like a pseudo fetch modeled after the web API and some Kafka stuff. So this one, we're hitting the Pokemon API to go figure out that Pikachu weighs 25 pounds and is electric type and that sort of thing. And the next thing here, so we do some templating to allow us to take this Pokemon from the staging environment and yada yada, so you can, of course, template between different environments with different values. Here we can run it with Snorlax instead. Save that. And all of this needs a rework, but it's okay. So then hopefully if we execute this, then this is going to go figure out that Snorlax weighs 143 pounds and push that onto a Kafka topic, because I was working with Kafka a lot at the time. So I figured, why not write a quick little module that can allow me to produce and consume from Kafka topics. And then just a third thing to then go and pull all the weights that have been pushed onto this Kafka topic, average them out and all this. So this is kind of the walkthrough that I embedded with the repo to figure all that out. So yeah, there you go. Snorlax, of course, kind of biasing this in his direction. I think the last thing was actually the ID instead of the weight in the last example. But yeah, there it is. This is, open source out there. Do not use it. It's not good. But all that to say, build your own tools, own your platform. It's fun. There's a CLI component to all of this. So if you want to do that instead, then you absolutely can. I can't demo that right now because similar problem to before, I cannot hold this in code. But there it is. So thanks so much.
it's on, it's in the middle of 36, and so parking might be a little bit of an issue next month. I don't know, maybe we can coordinate with capital tax. We'll figure that out. Yeah, so that will be on 6th Street. We'll see if we can get upstairs. Even if we can't get upstairs, we've got this huge, really nice back area. Would be plenty, assuming the weather possibly will be. Yeah, right. Yeah. And that's where we got the teachers tonight. So if you like the teachers,
Okay, so the other thing that I recommend, the other thing doing that particularly and then you can do the HTML thing where you're like, I want that bit, I want those 4 tags.